Brad Guy is the commander of an army of 350,000. Not soldiers, that is, but of infected machines he controls via his command center. From here, he attacks vulnerable hosts and steals personal and credit card data. Crime boss money laundering pays between $1 and $15 per record. This morning, at 10 p.m., Brad's morning, he turns his attention to vulnerable web applications.
Yeah, very nice. Let's try a little SQL injection first. It's so old, but it still works.
SQL injection flaws are a serious problem and are still very common, although it is quite simple to avoid. This type of attack exploits the trust relationship between the database and the application by tricking the application into including unintended commands. The impact can be severe, as it might lead to leaking or modifying database records, and in some cases can give attackers access to the full database or even the operating system. SQL injection is generally introduced through dynamic database queries that include user-supplied input. Let's have a look now at some unsafe Java code. This example is unsafe because it would allow an attacker to inject code into the query. The unvalidated customer name parameter that is simply appended to the query allows an attacker to inject any SQL code they want. Let's see what Brad Guy could do with this type of flaw. Instead of just typing in his name, Brad Guy adds a little bit of code into the field. What happens is that the code gets interpreted as a SQL query and is sent to the database. The database, thinking it is a valid query, sends back not only Brad Guy's information, but all other existing records for this field. Scary how many successful attacks still work like that. Sue and Cody are developers who understand that coding is not only about writing a cool app that works, but making sure it's protected against attack. Brad Guy's latest target is the company they work for.
No ways. Cody, did you know that SQL injection is still rated the #1 risk for web apps?
Yeah, crazy, right? And it's so simple to avoid.
Yep. I remember the main SQL injection controls like this. Protect SQL or lose data.
What do you mean?
Well, you take the first letter of each word. Protect SQL or lose data. Then P is for prepared statements, S stands for stored procedures, O for output encoding, L for least privileges, and D for data validation. So prepared statements or parameterized queries are actually the best bet when writing database queries. They're simple to write and easier to understand than dynamic queries. So you first define all the SQL code and then pass in each parameter to the query later. That way the database can distinguish between code and data regardless of what the user input is. So attackers can't just change the intent of a query even if they insert SQL commands. If an attacker tried to enter a command instead of his user ID, the parameterized query would just look for a username which literally matched the entire string, but not run it.
Yeah, another way is to use stored procedures, but be careful of stored procedures that appear parameterized, but may still allow injection under the hood. There's some security best practices that you need to follow in constructing and calling the procedures.
So what else should we do to avoid SQL injection?
Make sure you use output encoding. All untrusted input, whether from a user request or from within the database, should be HTML encoded before it's displayed. Also, don't display unnecessary user input. For example, redisplaying the username entered after a failed login. It's totally unnecessary.
You know what else is not necessary? Assigning DBA or admin rights to the application if it's not required. We should always minimize database account privileges to what's absolutely necessary.
I'm also a big fan of data validation.
Yeah, definitely. Doing proper data validation against untrusted data helps prevent injection attacks. You know, we all think untrusted data is most often user-supplied, but actually it could be any input from databases, web services, or other sources.
So basically, untrusted data is any input that can be manipulated, and we should always treat it as though it may contain an attack?
Exactly.
While we're talking about data validation, it's more efficient to make sure all input is validated on the server side and that centralized functions are used rather than ad hoc validation.
Yep, it's also easier for audit purposes that way. Have you heard that blacklisting should be blacklisted?
Yeah, so I hear. Whitelisting is definitely the way to go. Attackers can get through blacklist filters far too easily. This is why it's better to use a strong whitelist validation pattern, which is relatively easy to do with well-structured data like dates or ID numbers. And it's best to use a centralized library of input validation functions. Also, when string type data is received that is expected to contain data of a different type, for example a date, Typecasting should be done to automatically ensure that the received data is correct.
Agreed. It's a bit more difficult to validate free text fields like blog entries, but even those types of fields can be validated to some degree. So to summarize data validation, it should be centralized, use whitelisting, and typecasting, right?
Right, but don't forget about file uploads. All files that are uploaded to an application must be validated too. MIME type against a whitelist of types, file extensions against a whitelist of values, file names against a whitelist of characters. And the file should be stored in the database, not in the web root or on the file system. So how did Brad's day go? Not very well, because Cody and Sue know they need to protect SQL or lose data. Just another day for Cody and Sue protecting apps. Sorry for you, Brad guy.